Good afternoon, ladies and gentlemen. Welcome to Techgig webinar, our endeavor to empower techies. We believe that sharing of knowledge is the key of enhancing our performances and for our growth as professionals. With this principle in mind, Techgig has initiated a series of webinars conducted by industry experts to give a crisp insight of various domains. Topic for today's session is NAND Flash Memory. We are delighted to have Ms. Gnar, Associate Technical Manager at HCL Technologies as our guest speaker today. Vijay is currently working as Associate Technical Manager at HCL Technologies, Chennai. She has been working with HCL for the last 3 years and has over 6 years of experience in NAND Flash storage solutions. She has worked on various firmware code development and enhancement projects for 16-bit microcontrollers used in memory stick and USB mass storage devices based on NAND flash memory. Gentlemen, this presentation will continue for the next 45 minutes and we will take your questions after the presentation. In the meanwhile, you can post your queries through the chat pane available in the webinar software. Without further ado, I introduce you to our guest speaker, Ms. Vijaya.
This one, first we have to this one. Okay. Hello, Keshav, are you there?
Yeah, we can hear you and we can also see the presentation. Please start the webinar.
Hello.
Hello.
Not able to hear just speak.
Hello. Yeah, we can start the webinar now. Thank you.
Hello. Is this fast? Okay. Hello. But I am unable to hear your voice, Keshav. So, okay. Will you start with your with my introduction, or can I directly start with my? Okay. Sorry. Yeah. Let me start. அவரோடது work பண்ணல. Yeah. Which one? Already. So, good afternoon to all of you. This is Vijaya presenting this webinar on NAND Flash memory. This webinar will give you an overview of NAND Flash basics and what are the flash memory applications, physical organization, and other emerging storage solutions in the non-volatile memory area. So we are going to see all these things in this webinar. So today in NAND Flash architecture, which is dominating one in the non-volatile flash market because of its high capacity, low cost, and low power consumption, and also because of its scalable design, it became an ideal choice for the multimedia products which are entering into the market. So day to day the demand is increasing for the amount of storage in the all storage products. So also there is a rapid increase in the NAND flash capacity which satisfies this demand. So NAND flash has a very bright future in the upcoming years. So with this brief introduction, let's start our webinar. And so in today's webinar, we are going to discuss about NAND flash memory basics that is what is NAND, what's its performance, how the data is stored, all those informations we can see, and also the applications of NAND Flash, wherever it is used, those kind of information, and we are going to compare some of the flash properties with the other storage technologies like hard disk, NAR flash, and DRAM storage. And next we can see about physical organization of a flash, how the memory is internally arranged, and what are the basic unit of read and write operations. All those things will be covered under physical organization. Then we are going to look at primitive operations of a NAND flash. So the basic operations which are needed for a NAND flash to store the data in its physical locations. Then we are going to talk about the logical storage inside a NAND. Like when you copy a file or when you store a image, how the data is internally stored inside a flash. Those kind of you will get an idea of how the data is stored inside a flash when you copy a data or an image file. So the final section will give you an upcoming storage solutions in the industry like PCM, managed NAND, and MRAM, kind of non-volatile storage solutions. So let's start with NAND Flash basics. So this flash memory is a type of EEPROM, nothing but electrically erasable programmable read-only memory, which allows multiple memory locations can be erased or written in a single programming operation. Basically, the information is stored in array of memory cells, like array of floating gate transistor, which is called a cell. So each memory cell can store 1-bit information. The flash memory stores the data in the form of a charge or in the form of charge in the floating gate transistors. So nowadays you might have heard about a multi-level cell, which is MLC flash, which can store more than 1-bit information. So when you go more than 1 bit, so it comes up with the more complexion. So compared to MLC, SLC has high data reliability, which requires very less error correction coding and well leveling algorithm compared to an MLC flash. So and flash as we mentioned in the introduction point, the size is small and power consumption is also very low compared to other storage devices. And the main property is a non-volatile, so which doesn't require power to hold the contents of the flash, what was stored inside the physical memory. So these are all about basics of NAND flash, and we can see where it is used. So this flash memory become a preferred storage media in variety of consumer and industrial devices like USB drives, digital cameras, solid state disk drives, mobile phones, and memory cards. Predominantly in mobile phones and digital cameras, you can see all the internal data storages carried out with the help of this flash memory. So the next slide has a comparison with other storage technologies. We are going to compare the few of the flash properties, NAND flash properties with the hard disk, NOR flash, and dynamic RAM. So the first property is holding the data even without power. So almost NAND, NOR and hard disk are non-volatile type of memory, whereas RAM requires power to hold the contents. And the next property is read latency. So compared to hard disk, NAND has very good, it comes around 15 to 50 microsecond, whereas hard disk has a read latency in terms of milliseconds. If we go with NOR Flash, which has very good random access time compared to a NAND Flash. And in terms of write bandwidth, so compared to hard disk, NAND has lesser programming operations. For example, it can go up to 10 megabytes per second, whereas in hard disk we can go for 100 megabytes. Here the data storage is less compared to hard disk because of the programming operation time taken by a NAND flash. This is much less in case of a NOR flash, and almost hard disk and RAM has the same bandwidth. If you go for that, next property is the erase requirement. So when you do any reprogramming of a page, so NAND it should be erased before writing any data into a NAND flash page. So erase operation is required for NAND and as well as NOR flash, whereas there is no such requirement for hard disk and RAM. So based on this erase requirement, which decides the lifetime of the flash. So depends upon this erase cycles, the lifetime of NAND and NAR flash memories are decided. Whereas if we go for hard disk or RAM, it depends upon the either a physical damage or any other issues which is not typically inside the storage medium. And so if we see power consumption, all the non-volatile requires low power compared to volatile memories. And in terms of capacity, nowadays a single flash NAND flash memory can store data of around 16 GB. If you need more than 16, we can combine multiple flashes to get higher capacities. When we go for hard disk, so today we can get till 4 terabyte, and in case of volatile memories, it will be around 4 gigabytes. So relative to capacity, NOR flash memories are around 2 GB. You can store up to 2 GB per flash, which is the latest one in the NOR flash domain. Next, we are going to see about the physical organization of the NAND flash. So the pictorial representation, how a flash is internally organized, given in this slide. So each NAND flash memory consists of a memory array and flash bus. This memory array is subdivided into number of finite blocks. Again, this block is subdivided into pages. So the basic unit of erase operation is a block, whereas the basic unit of read or write operation is a page. So each page consists of data area as well as spare area. This data area and spare area size varies based on the size of flash as well as depends on manufacturer. These the number of allocated bytes may differ. This spare area is mainly used to store the error correction algorithm related information or to store the map table related information in a page layout. So NAND flash don't have any dedicated address pins. The flash bus protocol along with the other control pins are used to handle the address data and command bytes. So during any read or write operations, the data which needs to be transferred to the flash, which is first kept in the flash bus. So with the help of the control pins like CLE, ALE, CL is nothing but command latch enable, and our address AL is refers the address latch enable. So when we want to transfer any address to the flash memory, these control pins are used to transfer the data as a in terms of address to the flash memory. So this flash bus protocol is designed based on this ONFI standard. ONFI is nothing but Open NAND Flash Interface, which is a work group made out of 100 companies. They are giving a simplified NAND Flash integration solutions to all electronic products. So this flash bus, almost in all type of flash memory, is approved by the ONFI standard. So coming back to flash memory, so as I mentioned, this memory array is made up of finite number of blocks. So at the time of manufacturing, there could be some initial invalid blocks. So the flash which has pure invalid blocks will work similar to a block with all valid blocks. Only these invalid block informations need to be stored before doing any read or write operations. So some of the flash manufacturers stores these invalid block information inside the flash before it gets shipped into the market. So with that help of those invalid block information, we can design our system to handle those to handle the read writes without using the blocks. And also they guarantee that the first block, which is at the block which is block 0, present at the block address of 00, is guaranteed that it till 1000 erase cycles the data reliability will not be lost. So the important informations are stored in this block 0 of flash chip. So far we have discussed about what is NAND, what are its applications, and compare with other storage technologies how the NAND flashes differs with hard disk or RAM and Gnar flash, and about the physical organization of the NAND flash. Next we are going to see about primitive operations which are required for a NAND flash. So the flash basically it has 3 operations. One is reading a page, next is programming a page, then erasing the block. All these 3 operations are needed to store the data inside a flash. These the read operation fetches the data on a page basis from the target page, and during program operation the data is written on a page basis. Whereas during the erase operations, the erase is done based on block level, and at the end of erase all the values are reset to its initial values. The initial value could be 0 or 1, it depends upon the manufacturer. So let me talk more about this basic operations. So what happens while reading a page from a flash? So the internal flash memory can be accessed on a page basis. So whenever a read command is issued to the flash device, first the data is transferred from the internal memory to data registers. From the data register, the data can be sequentially output to outside memory. So from there it can be accessed to send it to transfer the data to host. Whereas when we do a programming, the again it's programmed on a page basis. Initially the page at which the data has to be programmed need to be transferred to the flash. So the programming starts with the address, loading of address followed by the data. So initially all these informations are loaded to the data register. From data register it is transferred to the internal flash memory after a specific program delay. So this programming delay may vary, depends upon flash type and page size of the flash. Next we are going to see about block erase. So each block can be erased over a definite number of cycles. So the programming or erase cycle is limited to 10,000 to 1 lakh, but again it may vary, depends on manufacturer and type of flash, whether it is an SLC or MLC. So based on that the erase count will be taken care inside a flash device. So next we can see about the limitations of NAND flash. So whenever we do programming, the pages should be sequentially programmed within a block. Once a page is programmed, it cannot be changed until the entire block is erased. Or if you want to reprogram a page, it should be erased, then only can be written with the new data. This characteristic is known as erase before write. And also each flash has a finite number of erase write cycles. So once it crosses that finite number, the data reliability may lose. So the storage device should take care of this erase cycles while storing the data into the device. So next we are going to see about how a logical data is stored inside a NAND flash. So when we take any picture or any files, it is stored inside a NAND flash from the host. This picture gives you an overall view of how the data is transferred from host to flash memory. So when a user tries to write a file, first the host issues a command to store the data inside a flash media through the file system. The file system takes care of sending command to the controller which is present in the storage device. The file system transfers the data along with the logical address to the controller firmware. So the controller firmware internally has a flash translation layer which takes care of converting this logical address into a physical address. For example, when we transfer a file to when we tries to write a file into the storage media, first it send the logical write first the file system send the logical write commands to the controller firmware, where the FTL finds a free location where the data can be stored. So once the data is written inside the physical medium, it note down the address of this physical area and corresponding to the logical address given. So that table will be maintained in the flash memory or in the storage device RAM. So when there is any host read command to retrieve the stored information, uh, the host issues a read command to the controller firmware. So again, based on the logical address given, the FTL is nothing but a flash translation layer, decodes the corresponding physical address and reads the data from the flash memory and transferred to the host. This is how a logical reads and writes taken care by a storage device which has a flash memory. So this slide has the summary of the logical data storage which we discussed in the previous one. So if FTL is nothing but a flash translation layer which resides between the host file system and the flash. So this FTL places the data at a free location in the flash, and it takes care of storing the physical information corresponding to each logical data. So this information conversion is called mapping information. So an efficient mapping algorithm will give you a higher performance. Storage solutions in the market. So we are going to discuss about MRAM, PCM, and managed NAND. MRAM is a type of semiconductor memory that uses magnetic storage elements to store the data. So compared to flash, it has very high data retention till 20 years. The manufacturer guarantee that till 20 years we can have this. We can have the data without any loss. And similar to flash, this is also a non-volatile, and compared to flash, the read-write performance is much higher. It will be in terms of nanoseconds, and also we can do unlimited read-writes. There is no degrade like flash. The main disadvantage is the stray magnetic fields. So the manufacturer should take care of adequate protection while shipping these products to avoid this stray magnetic field effect. It can be used as a SRAM or DRAM in the embedded systems. So similar to this, one more non-volatile flash memory, which is phase change memory. So this doesn't require any arrays. There is no need to program a page even to alter a single byte. And read latency is in terms of nanosecond, whereas when we, as we saw in the comparison table, NAND Flash has around 15 to 50 microsecond, but PCM, the read latency is around 50 to 100 microseconds. So this is also one of the non-volatile. And the final one is a managed NAND. So managed NAND is nothing but a raw NAND along with the hardware controller, which performs all the flash management features like error correction algorithm, wear leveling, and bad block management. And this support all popular interfaces like eMMC, SD, and other protocols. And these are the emerging non-volatile solution upcoming in the market. you can know more about GTech and ONFI are the standard, and you can get more idea about flash memory in the Wikipedia. So before we close this seminar, so this flash memory are suitable for the applications where a large amount of data has to be stored. Because of its some special characteristics, the system should be designed to take care of the block management, error correction algorithm, and VR leveling uh, to keep the data for a long time. So let's go for questions. If you have any questions, you can chat with me.
Hello. Are you able to hear me?
So we got a couple of questions from audience. So let's go over the questions. So this question is from Prashant Gandhi. He's asking what is the difference between a physical address and logical address. So the logical address, which is protocol dependent, and this address is transferred from host to the storage device. For example, if you have any known information about data storage or about file system, if we say our device capacity is around 32 MB, the data will be stored from 0 to 31 MB. So this is known as the logical address. Actually, the host will know only I have 32 gigabytes of memory and I can store from 0 to 31 GB. Whereas when you store inside a flash, flash doesn't know about any logical size or something like that. It knows only in terms of blocks, pages. Also, the translation layer writes the data wherever the block is free or the page is free. I can store, for example, I am getting a write from host for a logical address of 1000. Internally, I can store in any block, any page. If I store it at block number 20 and page number 30, so the FTL will do this mapping. Whenever I get the logical address of 1000, I should point to this block 20 of page 30. That is where my data is stored. So this is what the difference between physical address and logical address. So the next question is from Gaurav. He's asking in what applications HCL is using NAND Flash. So it's predominantly a confidential, but still I can give you an overall view. It's not directly HCL is using. We are working for a few of the clients. They were using the flash memory in their storage solutions. So we were working for that storage. And the next question is from Manish. Manish Savan. He's asking why NAND memory is not used in computers these days. The main issue, as mentioned in this webinar, is NAND has limited lifespan. Once it crosses that limited lifespan, it cannot, the data reliability won't be there. There could be data toggling. Even some of the data may last if the block is weird out. So the algorithm should handle all these wear out capability, and even then we can retain. For example, if the manufacturer gives the flash can work for some 1 lakh erase cycles, when it crosses more than 1 lakh, we cannot guarantee that the data stored inside a flash will be retained. So that is the main cause why it is not predominantly used in computers. Next, Kirti Patel. He is asking what is CLE and ALE. CLE is nothing but command latch enable and ALE is nothing but address latch enable. See, these are all control pins. So since flash bus is a common bus where we can transfer address, data, whatever it is, to the flash memory. So when I pass few bytes in flash bus, the memory should know whether it is a command or it is an address or it is a data. So to classify that, we have these control pins. So when the CLE goes high, and the data, whatever available in the data bus, will be taken as a command. And at that time, the ALE signal will be low. Whereas when ALE goes high, the data, whatever present in the data bus, will be taken as address. And Jocelyn asked one more question. Um, when does the lifespan start of flash memory? From the first use or from the date of manufacturing? It's from the first use. The raw NAND or the virgin NAND, which is after manufacturing, will be shipped out. So when we start using it, we write, and again
Your
we program
voice
used
is
to erase.
breaking.
So not from the date of manufacture. Only the typical erase cycles
Sorry
determine
for
the
interrupting
lifespan.
you. Your voice is breaking a lot.
And Kirti asked another question: what is the difference between data area and spare area? See, basically the data area refers whatever the logical data we got it from the host interface. If I want to copy a image file, the image file is further split into small chunks and it will be transferred to the storage device. So these data will be stored in the data area. The spare area is used for internal error correction algorithm purpose. So if you have any ECC calculation you can map it for every 512 or every 1000 bytes, you can do an error correction calculation and you can store those information in the spare area, and uh, which will be used while reading back the data from the device. And Rahul asked another interesting question: why the erase is one block and read write is for one page? Why not can be read write as well as erase as one page? See, the erase operation consumes more time compared to read or write. The read will be in terms of nanosecond, and write could be in terms of microseconds to do a programming operation. Whereas when you go for erase, it will take longer time. So by default, the manufacturer supports accessing of page for read-write operation and uh, erasing in terms of block. Hello. And uh, and Kirti asked about another question: why capacity of NOR is less with compared to NAND? See, the cost of NOR flash is very high compared to the same capacity of NAND. So the manufacturer are interested more in NAND flash rather than producing the NOR flash. Also, NOR flash has very low write speed. Only in terms of random access it is preferred. So uh, compared to NAND, there is no much increase in the capacity of NOR flash in today. And why there is a requirement for erase before write? This question is asked by Santosh. Uh, Basically, these are all basic properties of the flash. The flash memories are designed in such a way that it should be erased before reprogramming. Basically, under erased state, all that charges initially they are charged and when we program the data becomes 0. So again, when you want to write any data, it should be at its initial value, then only it can be reprogrammed. So for that, this is one of the basic property of the flash. So that's why we are going for this erase before write. Rahul asked a question of FTL writes mapping info somewhere in NAND Flash. What is that location? And Rahul, it is based on the design how we are handling in a storage device. There is no some specific location to store this FTL mapping information. It depends on how we design the FTL algorithm, and it depends for each algorithm whether if we want to store, we can store inside the flash, or even we can maintain it RAM, and whenever you connect the device to the host, it will the mapping information will be built and it will be again stored in the RAM. So it's depends on the implementation specific. And Nagaraja asked one question, which is what is the difference between NAND and NAR flash? Which one is the advantages? Basically, in terms of capacity, NAND flash is high. It will be available in terms of 16 GB and above, whereas NAR is around 2 GB. And if you go based on performance, the erase is very slow compared to NAND, and write is also very slow. Both write and erase operations are slow. Only the random access is fast compared to NAND. And also the cost is very high compared to NAND. So the NAR is preferred only if there is any requirement related to random access. If your device need any very high random access time, you can go for NAR rather than with NAND. But it's again what is the purpose of the device or where it is going to used. So depends upon that criteria we need to decide. So Santosh Kumar asked one question, how many pages will be there on one block? So the pages will starts from 32 page to 256 page. Again, it depends upon the manufacturer and capacity of the device. Each block, the page number of pages may vary from 32 to 256. But once if in one flash memory, if the number of pages are 32, then across all blocks the page count will be equal. Rahul asked a question, are these sizes like read or write to one page and erase to one block or fixed on based on the manufacturer? This depends upon manufacturer. So if a manufacturer accepts to program even lesser than a page, then we can program a page. But it's again depends on the manufacturer how they have designed the flash characteristics. How next question is from how the number of blocks decided for a flash memory. The number of blocks depends upon the capacity of the flash, and also how many pages a single block can accommodate, and what is the size of each piece. All these parameters decides the block count.
Okay, I think rest of the questions can be taken offline. Now we can conclude this webinar.
Session on NAND Flash memory. It was indeed an enlightening session. I would also like to thank our participants for their support in making this webinar a huge success. The recording of this webinar will be available on techgig.com by tomorrow. Gentlemen, the next session in Techgig webinars is happening today at 5 p.m. Today's session is third in the ERP system series, and topic for the webinar is Never Dying ERP Implementation Challenge. We will be having Mr. Amlesh Pore, Senior Manager, ERP at Cognizant Technology Solutions as our guest speaker. See you all at 5 p.m. Thank you.